Problem 24 is two problems that want us to use the elimination method to solve for x and y in a system of equations. The first part of problem 24 wants us to solve the system 4x plus 8y equals 20 and negative 3x minus 8y equals negative 17. Now when we use elimination, the first thing we want to do is get one variable to have equal opposite coefficients. That means the number next to the x needs to be the exact same number, in this case a 3 or a 4, but opposite, so one negative, one positive. Or we could choose to do the y, so we could have the number next to the y's be the same number, but one positive and one negative. We're lucky with this problem because our y's are already equal opposite coefficients. So we can move on to step 2. Step 2 in elimination is to add the two equations together. So when I add them together, I get x equals 3. Notice when we did that, our y's dropped out. That's why it's called elimination. We're getting rid of one of our variables. I know x equals 3, and from here, normally, I would solve for the variable that's left. This time we were left with just x equals 3, so we're actually done with step 3 also. Step 4 begins to look a lot like substitution. So for step 4, we're going to back substitute our value for x into one of our original equations. It doesn't matter which equation we choose, so I always want to choose the easier one. In this case, there's not really one that's easier than the other, so I'm going to plug it into the top. I have 4 times 3 plus 8y equals 20. I want to solve for y. So first I need to simplify, and then I work to get y by itself. So I subtracted 12 and then divided by 8, and I got y equals 1. I know x equals 3, y equals 1, and my fifth step, just like with substitution, is to make sure my answer is written as a coordinate pair. The coordinate pair is our x first, then our y, so 3, 1. Step 6 is to check our answer. I need to make sure that I plug it into both equations. It could only work in one, and then it wouldn't be the right answer. It needs to work in both equations. So when I plug in 3 for x and 1 for y in the top equation, I need to work it out until I get just one number on both sides. In this case, I got 20 equals 20 after I simplified. That's the same number, so that checks out. In the bottom equation, when we work it out, we get negative 9 minus 8 equals negative 17. That is the same number also. Negative 17 equals negative 17. That checks out also. So 3, 1 is our correct answer. The second part of problem 24 wants us to solve the system 2x minus 4y equals 4 and x plus 3y equals 12. This is just a little bit harder than the first part of problem 24. Remember that our first step is to make one variable have equal opposite coefficients. Well, in this case, I can choose to do the x's or choose to do the y's, but neither one of them are done for us already. So we're going to have to multiply one whole equation by some number that's going to make the coefficients, the number next to the variables, be the same thing but opposites, one positive, one negative. It's a little harder to do our y's here because 4 doesn't go into 3 and 3 doesn't go into 4, so I'd have to multiply both equations if I wanted to use y. However, x is nice. Okay, I can multiply the bottom equation by a negative 2, and then I'm going to get the same number in front of my x, but an opposite sign. So that new equation is going to be negative 2x minus 6y equals negative 24. Notice I multiplied the negative 2 times each term, not just by each term on the left side. I also had to multiply it by what was on the right side. Now that I have that new equation, step 2 is to add the new equation with the other original equation. So I'm going to bring down 2x minus 4y equals 4 and add them together. Again, my x's drop out. This is elimination. We're getting rid of one of our variables. Negative 6 minus 4y is negative 10y, and negative 24 plus 4 is negative 20. Step 3, I want to solve the equation for the variable that's left, for for the remaining variable. So negative 10y equals negative 20. All I have to do is divide by negative 10, and I know y equals 2. Step 4. I need to back substitute, and now we're doing exactly like we would in substitution. I know y equals 2, so I can plug 2 in for y in one of my other equations. I'm going to choose the easier one, so I'm going to choose the bottom one. X plus 3 times 2 equals 12. That's x plus 6 equals 12, and x equals 6. So I know my answer is x equals 6 and y equals 2, and I need to write that answer as a coordinate pair. So my answer is 6, 2. Finally, the directions of the problem ask us to check our answer. So as I check, again, make sure that you plug this into both equations. So 2 times 6 minus 4 times 2 equals 4. That's 12 minus 8, so 4 equals 4. It checks out of the first equation. When I plug in 6 and 2 for the next one, I get 6 plus 6, or 12 equals 12. Again, that works out.